let's look at the graphs of y equals some number a sine x and y equals b cos x. And then let's have a look at what we would get if we added those two graphs together. So y equals a sine x and b cos x. So let's go to the graph software, and I've drawn in the graph of a cos x, where we're starting off with a is 1, so it just goes up to 1, so that's our cos curve, and this is b sine x, so b is 1 as well to start with, so that's our sine x curve. Now if we add those together, a cos x and b sine x, well, we could look at a nice easy point. So if we add 0 plus 1, that would be 1, so we'd have a point there. Another easy point would be this one here, so that's 0 plus 1 must be 1. Here would be 0 minus 1, which is just minus 1. And here we've got 0 minus 1, which must be minus 1. And over here at the end, it's 0 plus 1, which must be 1. Now this would be another fairly easy point. So we're adding the red one plus the blue one, so that would be the same amount again, so it's approximately there. This one here, it's the same amount up as it is down, so if we add those two together, we're going to get 0. This one here, we're going to add that much, and then add that much, and we go there. So if we think about joining up those points, I'll do another one here, this would also be 0. So as we go from here to here, we can probably see that we're actually going to, I've done a bit of a wobbly line there, it's actually going to increase. And then again, as we go from here to here, you can probably see that it's an increasing. And if that bit there between here and here is increasing, because it's symmetrical, then that one must do the same, but going down. So if we join up these points, I haven't drawn those very well, but we get the general idea. It must look something like that. So I'm just going to perhaps draw that in now. And we've got a sine x plus b cos x. It was the other way around, so it was b sine x and a cos x, and I'll just put y equals. And that would be our graph. So I'm going to take away all those scribbles. And let's just delete those scribbles. So we've now got the purple curve, which would be the sine x plus cos x combined. I'll just label that one again. So there we are, that's our cos curve over here. Now what happens if I change the A and the B? Can we sort of think about what's going to happen to this maximum point here and the maximum point there? And can we also think of a possible equation for this curve here, the purple one, when we've added them together? So I'm going to just change the A and the B. So let's change B. So I'm going to change B to 3. And then I'll change A to 4. So we've got A is 4. And we've gone off the curve there, so we could perhaps just shrink that a little bit. So we can see that the maximum point seems to go to here to 5 and to minus 5. So can you see a relationship between the highest point for the cos curve, which is 4, the highest point for the sine curve, which is 3, and the highest point of the combined curve is 5. So is there a relationship between A, B, and this maximum point here? And can you think of an equation for that curve there? Now, let's go back to the slides. And we were thinking about what does the curve look like, which we'll talk about in the lesson. Where's the minimum point and where's the maximum point of that curve? So have a think about that. We'll talk about that in the lesson. Now, the next thing we're going to look at is expanding this r times cos x plus alpha. And we did that in the lesson with our addition formulas. So we should know what that one is. And it's cos x cos alpha minus sine x sine alpha. And we need to multiply by r because of the r over here. Right, the question is, can we express the following expression in the form r cos x plus alpha, where alpha is as small as possible and r is a positive number? So let's have a look. So we're going to change 8 cos x minus 6 sine x into something that looks like this. So first of all, let's expand r cos x plus alpha. And we already did that. So we've got r cos x cos alpha minus, well, it'll be r sine x sine alpha. Now we can see here that we've got a cos x down here and something next to it, which is cos of a fixed angle alpha. So it's just a constant, and that must be the same as the 8. And then over here, we've got a sine x, like the sine x here, and in front of it, another constant, which this time is sine alpha. So sine alpha must be the same as 6. So we've got 8 must be cos alpha, and 6 must be sine alpha. So we've got two equations that we need to solve. So method would be square them and add them. So square both sides and then add them. So that gives me r squared sine squared x plus r squared cos squared x equals 8 squared plus 6 squared is 100. And I've made a slight error here. When we did our equations, it should have been r cos alpha and r sine alpha because of the r over here. I've forgotten to put those in, but I've put them in the equation down here. Next thing, I can simplify that, so we end up with r squared equals 100, and that's because we can take out the r squared, and then we're left with sine squared plus cos squared, and we know that sine squared plus cos squared is 1. So we're left with 1 times r squared equals 100, so therefore r must be 10, because we're told that r is positive. Right, I've written that out here. Again, I've forgotten the r here. It should be r cos alpha and r sine alpha. And the next thing we need to do is to find alpha. And the way we do that is we divide our two equations. So we're going to divide r sine alpha and r cos alpha, and then divide 6 and 8. So the r actually cancels out this time, so we should have an r here and an r here, which will cancel out. Let's go back there. So we've got sine over cos, which is tan, is 6 over 8. And then to get the angle alpha, we do our inverse. Tan of 3 over 4 is alpha, which is 36.9. So we can write down our expression now. So we know that 8 cos x minus 6 sine x is equal to 10 cos x plus 36.9. Now I'd like you to have a go at one yourself. So you've got 3 cos x plus 4 sine x. And this time to do that, you're going to expand the r cos x minus alpha this time rather than x plus alpha. And I'd like you to do that for next lesson.